Okay, so let's look at an example scenario. Let's say that you have a UI or a mobile application or any other internal or external or even backend processes uh, that basically is going to use an API to basically place the order. So for just to make this easier, let's say a user logs into your website and he places an order, and that order goes through the API, which takes the order, and then it places the order in your database. It will basically queue the order for processing, and then you have something on your backend called order management system, which is going to pick up the order from this queue, and then it's going to do basically three things for simplicity's sake. So first one is to validate the order, and the second one it will process the order, which is nothing but fulfilling the order, and the final one is to send a receipt to the user to say that the order is successfully placed, and you can expect the order to be delivered on such and such date or something like that. So this is a very simple scenario. So let's see how why this scenario is inefficient and how distributed computing can help here. Let's look at the time consumption for this order management system. So because distributed computing comes really into play on the backend processes, we are basically going to ignore the top bit because that's out of scope for this session. So the bottom bit where the backend process is, let's look at this order management system in a little more detail in terms of the amount of time it will take for it to complete its task. Okay, so to keep things simple, let's say that it takes 1 second for each of these tasks. So it takes 1 second to validate the order, and 1 second to process the order, and 1 second to send a notification to the user. So what that means is it's going to take 3 seconds to process a single order, which comes into this order queue. So let's say that your company is going to receive about 100,000 orders per day. Then for this system to process all that order, it's going to take basically uh, 3 seconds per order, which means 300,000 into 3, which is going to be 300,000, which means it's going to take approximately 3.5 days to process all the orders that you receive on any given day, which, as you can imagine, is not a good system. So if the user has to wait 3.5 days to receive a notification saying that we have successfully received the order, it's not going to be a huge good system. Plus, every day you'll get more and more and more orders. So, for example, if every day you're getting 100,000 orders, then that 3.5 days is going to go exponential, and eventually you'll have more than like a million orders to process, and you don't have time to process all of them. Okay, so let's have a look at how we can speed things up. So if you notice in the previous scenario that I've shown you, the major problem that we have is this order management system. It was only able to process one at a time. So imagine if we introduce multiple instances of that same system, order management system. So for example, the first instance will pick up the first order, and then the second one will pick up the second order, and the third one, and then fourth one, the fourth, and so on. So it will be tricky to configure it in a database, but we can use some sort of locking to make sure that the instance doesn't process the order twice, and there are various mechanisms to do that. So let's say we achieve all of that, and then we increase the instance count to, let's say, 4. Then what we have done is we have effectively reduced the overall time by 4. So for example, in the previous scenario, it took us 300 seconds to process all the orders on a given day. So now it would be reduced to 20 hours, which is great, considering we previously we took 3.5 days to process them, but now we are only taking 20 hours. But this is just an example. So this number 4, you can increase that to any number. Say for example, you can increase that to 10, 20, depending on your requirement and the number of orders you're receiving. So that's one way to solve this problem. But is that efficient? So that's what we're going to look at in the next slide. Okay, so we have added 4 order management system in the previous scenario. Uh, So as I mentioned, we can add 10, we can add 100, or we can add any number as long as the order queue can handle that. So what, even though we've effectively solved the problem we've been having, did we do that efficiently? Can it be improved? So let's take a deeper look into what actually is happening. So what we originally saw was each of the individual tasks within that order management system, each of them are taking 1 second each. We still haven't reduced that time by doing any of this. Uh, Frankly speaking, distributed computing is not going to help you there. Distributed computing is all about parallelizing tasks as much as we can. So if you want to reduce that timing, you have to look at your business process and your downstream systems and see if you can do anything there. But the problem that we had with the previous solution, the solution where we increased the number of instances of order management system, it was even though we increase the speed, even though we parallelize the process, our order management system, it can still only do one order, and when it starts the order, it has to go through all three steps to complete it before it is ready to pick up the next order. So for example, if we take just one instance, so while it's processing an order, even though it has the capability to, it has the resource to do the validation, it doesn't do the validation because it needs to finish the notification of the first order before it moves on to the validation of the next order. So basically, it has to complete one order fully before it moves on to the next order. So effectively, if you are on the notification step, so the previous two steps, if they were going to take 2 seconds, the next order is effectively waiting 2 seconds while it actually could have been processed by that time. So that's why this system is very inefficient, and we could improve it in a better way. So the way to improve that is using distributed computing properly. So this is sort of parallel processing, but we haven't actually explored distributed computing yet. So let's have a look at that.